Hi, welcome to Math Antics. In this lesson, we're going to learn about ratios. Well, what in the world's a ratio? Well, let's look it up in a math book to find out. It says here that a ratio is a comparison of two numbers by division. Well, that's true, but it's also a little confusing. And it's confusing because most of us think of comparing numbers as trying to decide if a number is greater than, less than, or equal to another number. But with ratios, we're not trying to compare numbers like that. Instead, we're really trying to see how two numbers relate to each other. And so at Math Antics, we like to think of ratios as a relationship between two numbers by division. Okay, but how do you compare or show how two numbers are related by division? Well, to see what the by division part really means, let's look at an example of a ratio. Excuse me, that's not a ratio, that's a fraction. Oh, it's a ratio all right. Mathematically, ratios and fractions are basically the same thing. It's just that when we use a fraction in a particular way, we call it a ratio. Well, sure, everybody knows that. Well, like I was saying, ratios are basically just like fractions. The difference is how we use them to describe things in the real world. To see what I mean, let's look at examples of how we could use the fraction 1 over 2 and the ratio 1 over 2. Mathematically, these are both the same thing. They're just the division problem 1 divided by 2. But in the case of the fraction, we usually treat it as if it's just a single number. For example, at lunchtime, you might eat 1 sandwich, or if you're really hungry, you might eat 2 sandwiches. But if you're not very hungry, you might just have half a sandwich. We can use the fraction 1/2, just like we use 1 or 2 to show how many sandwiches you eat. It's just that in the case of 1/2, we know that it's only part of a sandwich, just a fraction of one. Now let's see how we can use the ratio 1 over 2. With a ratio, we don't treat it as if it's just a single number. Instead, we pay close attention to the top and bottom numbers because we use them to refer to different things. For example, let's say we're planning to go on a picnic. And for every 2 people that are going on the picnic, we're only bringing 1 sandwich. In that case, we'd say that the ratio of sandwiches to people is 1 to 2, or 1 sandwich per 2 people. Do you see the difference between our fraction and our ratio? The math part of each of them is the same. But with the fraction, both the top and bottom numbers are referring to the same thing, the sandwich. However, with the ratio, the top and bottom numbers are referring to different things, sandwiches and people. The fraction shows a part of something, but the ratio shows a relationship or a comparison between 2 different things. And you can see that they're the same thing mathematically, because if you did have the ratio of 1 sandwich per every 2 people on a picnic, guess how much of a sandwich each person would get? Yep, half a sandwich.
Let's go ahead and let's write a definition for ratio in our notes. A ratio is the relationship, like Mr. Math Antics talked about, between 2 quantities that have the same units. Ratios and fractions are similar, yet they're different. So we can show ratios in 3 different ways. Find the fraction form box in your notes and let's just write an example of what that would look like. We're going to use variables. You just use the fraction bar. You're comparing some value to another value. You can use a colon, A for every B. Another form is literally using the word to. I'm comparing A to B. Let's practice writing ratios using a bag of marbles. And we're going to use our knowledge of fractions because ratio and fractions are similar, yet they're different. What is the ratio of green to red marbles? Here, I'm comparing a part of the total marbles in the bag to another part of the marbles in the bag. So technically, green to red is not a fraction because a fraction compares a part to a whole. It gives you a part for a value. Here, I'm comparing a part to a part, but we can still write it in fraction form. And the order that we write it matters. So I want green, the number that represents that, to come first. How many green marbles are there? 4. How many red marbles are there? 3. So the ratio of green to red would be 4 to 3. I always start with writing it in fraction form first, even though this is not a fraction, because what this ratio is saying is for every 4 green marbles, there are 3 red marbles. Since ratios and fractions are similar, we also want to use our same knowledge of working with fractions, like asking, can we simplify? 4 to 3, do 4 and 3 share a factor besides 1? No, they do not. So I can't simplify it. It is in its simplest form. Something else that's really important to talk about is I wouldn't change 4 to 3 into a mixed number, because a mixed number is not a relationship between two numbers. So when we're working with ratios, we don't ever want to change them into a mixed number. However, I can show 4 to 3 in the different ratio representations. I can use a colon. The 4 would come first because I'm referring to green to red. Or I could use the word 2, 4 to 3. Make sure you have all three representations down in your notes. Let's look at the next example. What is the ratio of blue to total marbles? This one right here, 7th graders, is actually a fraction because you're taking part of the whole. How many blue marbles are there? 2. How many total marbles are in the bag? 10. So blue represents 2/10 of the whole, or for every 2 blue marbles, there are 10 total marbles. So if you had 4 blue marbles, how many total marbles would there be? 20. We could use that relationship to keep building. Now, before I move on and write it in the other forms, I'm going to ask myself, can I simplify 2/10? Yes, I can. 2 and 10 share a factor. It's 2. That's going to give me 1/5. For every 1 blue marble, there are 5 marbles in the bag. Now, I'm going to write that using the colon, and I'm going to write that using the word 2. Here, I could say blue represents 1/5 of the bag. If I was going above, I can't say green represents 4/3 of the bag. That wouldn't make sense. And that's because the very first question there is a part-to-part ratio. Let's look at another example here. What is the ratio of green and blue to red marbles? So I need to add up the green and the blue. What would that be? 6. How many red marbles are there? 3. I'm going to write it in fraction form first, so that would be 6 to 3. I'm going to see if I can simplify. Do 6 and 3 share a factor outside of 1? Yeah, they share 3. I can divide both the top and the bottom by 3 to get 2 to 1. Now let's pause for a moment. We are so used to seeing that and going, hey, we're just going to write it as 2. But the definition of a ratio is the relationship between two quantities. The minute you take the 1 out of there, you don't have 2 values. So when we're dealing with ratios, we're not going to simplify that just down to one number. We're going to leave it as 2 to 1. Let's write that using the colon, and let's write that using the word 2. Are you starting to see even more how ratios and fractions are similar, yet they're different? Now that we've reviewed what ratios are, how they're similar to fractions, yet different to fraction, we really got to think about how we're interpreting a ratio. Let's talk about equivalent ratios. So look at my fish bowls here. What is the ratio of orange fish to black fish in each bowl? Remember, order that we write a ratio matters. I want orange to come first and then the black fish. So looking at the bowl on the left, how many orange fish are there? 2 to how many black fish? 5. So the ratio of orange fish to black fish is 2 to 5. For every 2 orange fish, there are 5 black fish. This is a part to part. So we wouldn't say that the orange fish represent 2/5 of the fish in the tank because there are not 5 fish in the tank. There are 7. They represent 2/7. Look at the second fish bowl. How many orange fish are there? 4 to how many black fish? 10. My question is, are those ratios equivalent? Do they represent the same value? There are a couple different ways we can think about this. Right away, I see, from 2 to 4, well, I would just have to multiply by 2. I know I can use my knowledge of fractions when it comes to working with ratios, but I have to be careful about how I interpret the ratio. 5 times 2, does that give me 10? Yeah. So are these two ratios equivalent? Yes, they are. Another way to look and see if these two ratios are equivalent, change them into a decimal. Take your top value and divide it by your bottom. 2 divided by 5, that gives me 4/10. Well, 4/10, that's a nice one. That's a fraction where I can go, how I read it is how I write it. They're the same in decimal form. These two ratios are equivalent. Another way that I can look to see if these two ratios are equivalent is to simplify them. 2 to 5, can I simplify that? It already is simplified. 4 to 10, can I simplify that ratio? Yeah, I can divide both the top and the bottom by 2 to get 2/5. And look, both those ratios are the same in simplest form. So are the ratios equivalent? Yes, they are. And we figured that they are equivalent by looking at it a few different ways. We multiply, or you could divide, the top and bottom number by the same factor, like how you find equivalent fractions. We changed them to a decimal. If they have the same decimal value, they're equivalent. And we simplified them. If they're the same in simplest form, they're equivalent. Find the next chunk in your notes. On the left-hand side, how do we find equivalent ratios? We have those 3 ways that we did with the fishbowl problem. Pause the video, and what you see in red on your screen, go ahead and copy that in the left-hand side of your notes. We need to determine if those 4 ratios that you see are equivalent. Let's practice using these 3 strategies. Our first problem is 14 to 20. Is that the same as 7 to 10? Maybe you see right away that, well, 14 to 7, I would be dividing by 2. 20, can you divide that by 2 and get 10? We're dividing by the same factor. Therefore, these 2 ratios are equivalent. Make sure in your notes you have the arrows and the divide by 2 like you see in front of you. The second example, this time we have to write it out. 32 comedies for every 4 dramas is the same as 72 comedies for every 9 dramas. We're comparing 32 comedies to what? 4 dramas. So let's set that up. Is that the same as 72 comedies to 9 dramas? This time, divide to see if they give us the same value. Take 32 and divide it by 4. What do you get? 8. Take 72 and divide it by 9. What do you get? 8. Those are the same numbers. Those 2 ratios are equivalent. Let's look at example 3. 6 to 4, is that the same as 15 to 10? This time, let's simplify. I don't see how I'm going from 6 to 15, what I would be multiplying by there. I could change them into a decimal, but let's practice simplifying. 6 and 4, can you simplify that ratio? Yeah, you can divide both of the values by 2 to get 3 to 2. And we're going to leave it in that improper fraction form because a ratio compares 2 values. Can you simplify 15 to 10? Yeah, I can divide both of those by 5. And I would get 3 to 2. They are both 3 to 2 in simplest form. That means they are equivalent ratios. Let's look at number 4. We have 9 is to 27 as 18 is to 28. Pause the video. You determine if those 2 ratios are equivalent. Using the first strategy, do you see how you're going from one to the other? Meaning, how am I going from 9 to 18? Well, I'm timesing by 2. Okay. So 27 times 2, does that give you 28? Nope. You're not multiplying by the same factor or dividing by the same factor. Those ratios are not equivalent. Maybe you changed them into a decimal. 9 divided by 27, well, that's 3/10 repeating. And 18 divided by 28 doesn't give me a nice decimal, so I did an approximation. It's about 64 hundredths. Are those the same decimal? Nope. Maybe you changed them. You simplified both those ratios. 9 to 27 in simplest form is 1 to 3. 18 to 28 in simplest form is 9 to 14. Are they the same in simplest form? Nope. Those 2 ratios are not equivalent. So we're going to put a slash through that equal sign. Let's move on to the next section in our notes, and we're going to figure out or remind ourselves, how do you compare ratios? The Rover Animal Rescue has 5 cats and 8 dogs available for adoption. The Park Animal Rescue has 10 dogs and 7 cats. Which animal rescue has a higher ratio of dogs to cats? What are we being asked to find? Which animal rescue has a higher ratio of dogs to cats? Box that in. Let's answer that. Blank had a higher ratio of dogs to cats. Let's go line by line, look for important numbers and important words that are going to tell me whether to add, subtract, multiply, divide. The Rover Animal Rescue had 5 cats and 8 dogs. Well, I need to know how many cats and how many dogs. The Park Animal Rescue has 10 dogs and 7 cats. Ooh, this one has dogs coming first and then cats coming second. Which animal rescue has the higher ratio? That's a word that tells me to compare 2 values. of dogs to cats. Since we're working with a ratio, order matters. I need to make sure that the value for dogs is on top and I'm comparing that to cats. So I want to be mindful of that. Let's look at the Rover Animal Rescue first. They have 5 cats for every 8 dogs. We need to flip that. Dog needs to come on top. So it's 8 dogs for every 5 cats. Then let's look at Park Animal Rescue. That has 10 dogs for every 7 cats. Dogs needs to come on top, so 10 for every 7. Now we're comparing. We want to see which one has more, a higher ratio. Whenever I have to compare and I'm looking at things in fraction form, I like to change them to a decimal. It's easier for me to just compare when things are in decimal form. Write that over in the left-hand side of your notes. Compare using decimals. 8 to 5, change that to a decimal. Go 8 divided by 5. What do you get? 1.6, right? All right, let's go ahead and let's take 10 and divide it by 7. 10 divided by 7, what do you get? Ooh, we're going to have to do an approximation here, so about 1.4. Which decimal is bigger? Which decimal has a higher value? Yeah, the 1.6. So Rover Animal Rescue had the higher ratio of dogs to cats. Pause the video and you work on this one. Come back and check your answer with mine. If you're not sure what the word pro bono means, that's where you're taking on a case and you're doing it without charging any money. So we want to see who had the lower ratio of paid to pro bono. That order matters. The number that goes with paid cases needs to be on top. The number that goes with pro bono cases needs to be on the bottom. If I'm looking for Doug, he has 20 paid to 18 pro bono. And Katie has 15 paid to 14 pro bono. Which one had the lower ratio? So again, you can compare them using decimals. So when I did that, I had to do an approximation. Now, which one was smaller? The second one there, the 15 to 14, which goes with Katie. So Katie has a lower ratio of paid to pro bono cases. Anything you need to change in your notes, go ahead and do that using mine right now. Otherwise, if you're ready, let's go on to summarize everything that we did in this lesson. Ratios are written with the same units. There are 3 ways to write a ratio, and the order that you write them matters. Pause the video so that you can finish writing that for your summary in your notes.